All right, we're looking at which triangle is similar. The symbol here got mixed up. I will check to see how confused that made everybody. This weird looking D is supposed to be just a symbol for a triangle. I don't know if it came out poorly for everybody that way or just for me, but all those things that say weird symbol there should mean triangle, like triangle DEF or triangle LMN. I hope you figured it out. So if we're testing if these two triangles are similar, we're going to look for a ratio. So yellow line compared to yellow line. I've just highlighted here in yellow and green two sets of lines that are at least intended to be corresponding. So like AAB compared to PQ or LM or XY, however long these yellow segments are, or DE. And the green one is, the green one is AC. And then we have our one to compare it against here. I don't know what these ones are going to be. We'll try with all of them. So let's do from left to right. So we got AB over something is equal to AC over something. So AB is always going to be 5 and AC is always going to be 8. So I could do that for all of these ones. I'll say 5 and 8. And for this one I can say 5 and 8. I'm just writing out the length of this 5 and this 8 to compare it against. And I'm going to set them on the top of that fraction just because I want to not lose my track, not lose my train of thought. And we're just going to replace the bottom part here with the equivalent yellow number or the equivalent green number down here. So for the first one, it's 10 and 16. And 5 over 10 is half, and 8 over 16 is a half, so this one's totally congruent. The first one we tested is the right one. There it is. But let's test the other ones. So is 5 over 6 the same as 8 over 9? You can test by decimal value. 5 over 6 is 0.83333. And 8 over 9 is not that. 8 over 9 is 0.88888. 8 repeating. So those two are not equal to each other, so these two are not similar triangles. Here, 5 over 10 and 8 over 21. 5 over 10 is a half. And 8 over 21, if we do this by reducing fractions, we could reduce this one to a half, and we could reduce this one to nothing, just 8 over 21. Those are not reducible to the same fraction. They're not equal. Last one here, 5 over 4 and 8 over 7. We can check by cross multiplication. 5 times 7 should be the same as 8 times 4 if these are similar. 5 times 7 is 35, and 8 times 4 is not 35, it's 32. So not similar either. So just triangle PQR is similar. Next, find the length of this line segment. For the length of the line segment, we've got a nice grid, so we can just draw in how far down and how far over we're making a right triangle in here. We can say we're going down 1, 2, 3 steps. And we're going over 1, 2, 3, 4, 5, 6, 7 steps. So if I'm looking for this one, I would do, by Pythagorean Theorem, I have to call this side C because it's the longest one, it's the hypotenuse. The other two, it doesn't really matter what I call them. A or B are pretty interchangeable. So 3 squared is 9, 7 squared is 47, and 9 plus 40 is 49. 49 is C squared. So that's 58. And if we take the root of both sides, then the root of 58 is 7.6. 7.6. You can see 58's there waiting to trip you up. But 58 would be a much longer line. So hopefully they didn't pick that one. Determine the length of the hypotenuse of this triangle. If necessary, give your answer to one decimal place. Same as the last question. This is the longest side. It's opposite of the right angle. So we can just do a squared plus b squared equals c squared. 10 squared plus 15 squared. equals c squared. 15 squared is 225. 10 squared is 100. Together we make 325. And if we take the root of that, we get 18.02, etc. It says to 1 decimal place, and then none of our choices have 1 decimal place. But, oh well. Choose our best answer anyway. It's 18. And just looking at these 150 and 325, there's no way this side is 150 units long or 325 units long. That's just too big. 11.2 also doesn't work because this side has to be the longest side. And 11.2 is not longer than 15. So even without doing any math, we could have chosen 18 as well. Here in this figure, we're going to find the measure of angle AOB. Angle AOB is this angle right in there. So the angle in this space. This angle we can see is going to be obtuse. And we know that it's going to be opposite of that one, which would help if we knew that angle. We don't. Or that it'll add up to 180 with this angle. And we do know this angle. So if we take 180 minus 87, we get 93. So this missing piece here has got to be 93 degrees. And that helps. I mean, it works because this angle is obtuse and 93 is also obtuse. This one, this one, this one are all acute angles, and this one just doesn't look acute. That's acute, so this one's got to be obtuse. Last one for this video, then flip over the next one. If angle 8 measures 50 degrees, so that's 50 degrees in there, which two angles measure 130? So 50 and 130 add up to 180 degrees. These are supplementary angles. So I know that this one is 50, this one is 50, and this one is 50. All of these angles I've just written in blue here are 50 degrees because these are transections, and we just know that pattern, I hope by now. But we're looking for ones that are 130 degrees, which means they need to add up to 180. So 50 plus something is 180. This has got to be 130. This has got to be 130. This has got to be 130. And this has got to be 130. So many choices. So which two angles measure 130? Well, angles 6 and 7, 2 and 3. So not angle 4, that's 50. Not angle 1, that's 50. Not angle, well, 4 again, that's 50. So it's angle 2 and 6. Okay, I'll stop this video here and start a new one for the next one.